Hello everyone, welcome to my channel. It's the 11th day of the days of code. Let's look at the problem today. So here we have the problem Re.findall and Re.finditer. So let's look at the problem statement. First, they have given us some examples over here. Re.refindall, the expression returns all non-overlapping matches of the pattern in string as a list of strings. So they are checking for a pattern over here. Re.refindall row string of \w, then from this website it returned all the matches over here. So let me show you. This w actually means returns a set of character of any word from A to Z, like that. So everything will be a match, so it returns http www, then hacker rank, like that. Next function Re.finditer, it returns an iterator yielding match object instances over all non-overlapping matches for the Re pattern in the string. So here we have does not return a list of the matches. We need to use a lambda function, a map function, that and a lambda function in order to get the same result as above. So that's the difference between both the functions over there. So let's see the task we have to do. You are given a string S. It consists of alphanumeric characters, spaces and symbols plus minus. Your task is to find all substrings of S that contains two or more vowels. So our task is to find two or more vowels. Let's note it down. Okay, wait a minute. Vowels. That's our task we need to find. Then what? Also, these substrings must lie between two consonants and should contain vowels only. So this two or more vowels should be between two consonants. So it should be consonant, then in between that two or more vowels should be there, then consonant should be there. So the format must be like this. So we need to identify such patterns. Then let's see the input format over here. Single line of input containing a string S. So this is the input that we have here. Then print matched substrings in the order of occurrences on separate lines. If no match is found, print -1. So if no match, then print -1. That's what we need to do. Then what? So let's see the output they have explained over here. So this is the output, and so E is located between consonant D and F. So here we have E, it's a consonant, D is a consonant and F is a consonant. So here 2 is a present, so 2 or more vowels are there, so this should be taken as a match. And similarly I, O, O, K and M between O, E, O between P and R, then 5 is between T and T. Okay, so they have given us here. So vowels are defined as A, E, I, O, U, then capital letter and small letter. Similarly, consonants, remaining alphabets, like that. So let's first import Re. Then we need to identify the pattern, right? Pattern or the vowels. We need to define for vowels. Vowels equal to, then make a like that. Inside that we can copy this out. Where is that? Okay, here they have given us A, E, I, O, U, AIOU as well as capital AIOU. So we just copied it out. Like we need to find these set of characters. We need to check for these characters are present or not. Not set of characters inside. So that's why we are using this character over here. So A to M. So they are checking for A to M over here. So similarly, we need to check for AIOU like that. So let's define consonants next. Consonants equal to, similar to that, we can just copy it out. Then similarly for the capital letter 2. Okay, we got the consonants too. Now we have to check for the pattern. So let's consider it as match, then Re.find. We need to find the patterns, right, and list them together. So let's write it as list. Then our pattern should be first there will be a consonant, then a vowel, then a consonant. So let's make it 3 of this like that. First vowel, then consonant, vowel. So let's format it. Format of, like here we can put consonant, then vowel, then consonant. So likewise we had to mention C equal to consonants, comma, V equal to vowel. Vowels, yeah, that's what we written over there. Then we have to take the text, right? So for the Re.findall, we need to first check for the pattern, then we have to put the text over here. So in order to take the input, we can like write input. Okay, input is there. So let's close it out. So now we have to check for the pattern specifically. So we have to check whether the pattern starts with consonant or not. In order to check that, there is actually a method over here. So it's shown over here. This particular pattern so matches the current position of the string is preceded by a match. So here is an example they have shown over here. This question mark, then less than equal to ABC, then DF. So it's check whether this particular ABC after like it returns the pattern after this ABC. So here we get DEF as output. It's known as positive look behind assertion. That ends the current position. This is called positive look behind assertion. We will find a match A, B, C, D, F. Since look behind will pack up 3 characters and check if the contained pattern matches. So we will get like that. So similar to that case, here it checks for hyphen. So the elements after the hyphen will be printed. So this is what we got over here. So after spam hyphen egg, so we will get egg over here as the output. So similarly we need to check for consonant, then vowel. So we need to print the vowels after the consonant. So the spam, instead of spam and hyphen, we need to put consonant over there. So we need to write the same pattern equal to C should be in curly brackets. Okay, like everything should be in curly brackets as we formatted it, right? So this also should be in curly brackets. So we did for the first part. Then for the second part, we'll be checking for the vowels, right? For there should be a pattern for the vowels too, that it should be 2 like here 2 or more vowels. We need to check for 2 or more vowels. So here for exactly specified number of occurrences, we need to use curly brackets for checking that. Let me show you with an example. So here the example hello planet, so they actually check for HE, then here curly bracket is added, then 2 is mentioned. So in between that there should be 2 elements. So here hello is printed, it's a match. So let's add another hello with 3 lines, then run the code. So it's still matched only for hello, as only 2 occurrences are checking, right? So if we add a comma over here, it actually means checks for 2 and more of the particular pattern. So let's run it out again. So here we got this hello 2 with 3L. So similarly, if we add how many number of hello, it will still print that, since it actually check for 2 or more. Okay, likewise we need to check for the vowels. So instead of here, we need to add another curly bracket, and inside that there we need to add the pattern curly bracket. So when we are doing a formatting, we will be like, if there should be 2 decimal places, we will be adding an extra curly brackets, right? So inside that we'll be writing like %2 or something like that, like 0.2f, like that. So instead of this curly bracket is for the formatting, and this is for the our pattern. So 2 comma, so we'll get all the vowels that are 2 or more. So similarly for the final part, we need to check all the vowels before the ending part. So likewise, here is another assertion called look ahead assertion. So here, for example, Isaac, this pattern over here, as IMOV will match Isaac only if it's followed by IMOV. So as in the case of IMOV, we need to put consonant, so it will match the vowel. Instead of Isaac, the vowel should be there, and as IMOV, the consonant should be there. So it will check for the vowels that are present before the consonant, like just the opposite of this case. So here no less than symbol is there, so we have to write that. So question mark equal to, so that part is done. So let's run the code. Let's print it out. Print sorry, match, right? Match. Let's run the code. Okay, what's happening here? Syntax unmatched means equal to vowel. Let me check what happened over here. I don't know. Showing some error. I don't know. Input. What's the problem with the input over here? Okay, I forgot to mention a over here. So then input, then our final bracket. So that's it. Let's run the code again. So here we got the output similar, like here EE, IOO, then OEO, EEE, like that. So we have to print it line by line. So in order to do that, we can adopt several methods. If match equal to none, here it's mentioned over here, if no match is found, we need to print -1. So if match equal to an empty set, empty list, then we have to print -1, right? And else we have to loop it out for I in match print I. So here we can check for length of match 2, right? Like if it is an empty set, so length of match is 0. So we can check for that too. Like we can do several methods over here to do the same thing. Let's run it out. So we got the test cases correct, and even there is one method like I have seen somewhere, print of dot join of like match comma o -1, like that. I don't know whether it works or not. What's happening here? It actually joined. Wait a minute. Let me add a new line. Okay, we got the same thing. Like it will check whether it contains a match. If it contains a match, it will join them with a new line. So we will get output like this. If not, it will print -1. So that's what this code works, similar to this one itself. Let's use the simplest way, then let's submit it. Okay, what happened over here? So we got a test case wrong. I don't know what's happening over here. So I think some mistake with this code. Match o -1. Don't know what happened. So let's check whether if everything is correct or not. This is correct. This is also correct. This is also correct. Consonant. Let's unlock it. What's the problem? It should be printed -1. So match a single character not representing this. So here I think this code did not work. I think there might be some problem in using that. Let's print the match. Let's see what's printing over there. For the test case too. Okay, still we are facing the same error. I don't know what's the reason. Let's try it with the old method. If length of match equal to null, then print -1, then else print in print I, right? So let's run it now. So we got it correct. Then test cases, still it's fails in match a single character not present in the list below. So this is the input format. Then we need to return -1. So our code fails. It's not the problem with -1. Let's copy the test case, then run custom test case. Let's paste it, then run the code. What is happening? No response on standard output. Means I did not understand. Print match, then what? Okay, our output is an empty list. So what's the problem with that? So len of match equal to this one, then print -1. So why is it not printing -1? I don't know why. It's -1, right? -1. Else len of match equal to oh my god, it should be 0, not that one. Okay, our is correct, then let's submit it. Okay, we finally got the entire test cases correct. So it was a problem with this function over here. So we got the entire test cases correct. So there is no need for adding capital letters as well as small letters like lowercase and uppercase. There is actually an attribute over here like this Re.findall contains the pattern, then the text, then there is one option, one more thing, flags. Like here flags is mentioned over here, flags is union of in blah 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 like that. So we have to define flags equal to re dot ignore case. It means if the pattern is uppercase or lowercase, it will still detect, so we don't need to put both over here. We can eliminate the uppercase, then only add the single thing. So let's run it again. Okay, we got the test cases correct, then let's submit it. Okay, we got the entire test cases correct too. So that's it for today. I think the video is helpful to you guys. If you find this video helpful, please like and subscribe to my channel. I'll be sharing the links to the official documentation of this regular expressions and this W3 schools in the video description, so that you can look on and read further about this assertions and so on. Okay, we can meet tomorrow with the 12th day problem.